Hello students, I am Sailesh Prajapati. Today I invite to you in the chapter number 8, last part, application of integrations. Yes students, in this last part I explain here two numericals remaining for the exercise 8, 18 and 19 and one of the two remaining miscellaneous examples, last two examples. All are big numerical, but here slowly I explain here. These are different type of questions. Find the area of circle, exterior part of the region bounded by the parabola y square is equal to 6x, and options are there. So it is a MCQ type questions, but actually it is 4 marks question. So first of all I must create both common region. So my common region is x square plus y square is 16 and y square is equal to 6x. This y square you putting down here. So x square plus 6x. So x square plus 6x minus 16. Make it splitting. 8 2s are. I mean 16 and 6. Yes, 8 2s are plus 8 and minus 2. So you will get minus 8 or x is equal to 2. One of the minus 8, one of the 2. Now here, possible to try x is equal to minus 8? No, it is not possible. 6 into minus 8, which is not exist. Because square value never negative and y square is equal to 6x. Possible there. 6 2s are 12. I mean y is equal to plus or minus root 12. Root 12 means plus or minus 2 root 3. It means students, common point here ready. Common points are simple to simple ready. One of the 2 comma plus or minus 2 root 3. In short, my drawing is ready. So I will show now properly my drawing is this. This is your y and x axis. And circle also known you x square plus y square 16. Radius is 4. So this is your circle students. 4 comma 0. Here exactly 2 0 because the middle point I defined here, and that is your 0 0. Here minus 4 0, 0 4 and 0 minus 4. Now students, you just draw here one of the dotted line with the 2, and because 2 comma root 3, sorry 2 root 3, and another 2 comma 2 root 3, and here 2 comma minus 2 root 3 b point. That is your parabolic region. Students, these are the parabolic region. This side also moving there. Y square is equal to 6x. And my target asking exterior region. It means this target I will achieve at the end of this sum. This is your target students. So very easy. Whole circular region you know, area of the circular region pi r square minus this and this circle part divide, it means this a1, a2, a3 and a4. These are the subtracted by the area of the circle. So first only I this calculate, after that circle area subtraction. So here fx become by the our circle y square becomes 16 minus x square. So fx become y under root 4 square minus x square, and parabolic part is a y square is equal to 6x. I will take here gx is a 2y under root 6 with root x. It means root 6 with root x. So I only explain about this part, internal region, then after externalize circle minus. So area of both internal region is 2 times 0 to 2, but this part is bounded by the parabola, and parabola I will told here gx plus 2 to 4, it means this region by this circle it is fx, and simplify solution. So students, here 2 as it is, 0 to 2, what is my gx? Root 6 root x dx plus 2 to 4 fx, this one fx, under root 4 square minus x square dx, 2 to 4. Yes, it is circular part applied to 2 to 4, 4 square minus x square. Now this total calculation I first calculate, and that is this region, and circle minus that, then your answer create. So students, I start my small journey to integrations part. Yes. So calculations very easy. It is 2 times, and the root 6 is outside, x raised to 3 by 2 by 3 by 2, and boundary is 0 to 2 plus 2 times, again the multiply inside, and the formula is x by 2 under root 4 square minus x square plus a square by 2 sine inverse, but boundary is 2 to 4. Again repeat, 4 square minus x square is x by 2 under root 4 square minus x square plus a square is 4, and sine inverse x by a, x by 4. So students, simplify the limits. 2 to the root 6 as it is, it is 2 by 3, and here apply 2 raised to 3 by 2 minus 0. Students, I think these two common and cancel. So put it the 4 square minus 4 square plus 16 sine inverse 4 by 4, upper limit minus lower limit is 2. So 2 under root 16 minus 4 plus 16 sine inverse 2 by 4. And now calculate the answer. So your answer is 2 root 6 I written down root 2 and root 3, and 2 by 3 is as it is. Here also 2 raised to 1, but 2 raised to half. This simplifications. In short, totally very shortly calculate I 4 here 0 sine inverse 190 pi by 2 minus 2 root 12, and minus plus minus 16, it is half. When half, pi by 6. So you finally did 2 to the 4 to the 8, and this to 16, root 3 and root 3 by root 3 plus 0, 8 pi minus 2, but root 12 is a known, 4 3s I mean 2 root 3, and minus this cancel, 8 2s are 3 2s are, this I mentioned students here. So your final destination is this, and these are common taking, 16 by root 3 minus 4 root 3, and 8 pi minus 8 pi by 3, and simplify on it, simple calculation. So here LCM taking 16, 4th is a 12 by root 3, and here also 8th is a 24 minus 8 pi. So students, you did 16 minus 12, it is 4, yes, by root 3 same as, and plus here 16 pi by 3, yes, 16 and 8, 24 minus 8, 16. This part is a major part, no, it is minor part, but I want to measure part, so circle area minus this, they get the answer. So students, finally done or required area of exterior region, that easily I finished there. So required area of exterior, area of external region, which is area of circle minus this 4 by root 3 plus 16 pi by 3. Students, area of circle, having circle areas known, you radius is 4 here, yes, it is 4 square, the same is, so it is 16 pi minus 16 pi by 3 and minus 4 by root 3. So 16 pi common taking very easily. Other is a 1 minus 1/3 and 4 by root 3. It is 16 pi, it is 2 by 3 minus 4 by root 3. So your answer is 32 pi by 3 minus 4 by root 3, and according to options your correct answer is I think C, C option printed in your book. Check your options, C options, which is 4 by 3, 8 pi minus 1 by root 3. Yes, 8 pi minus root 3. Check your options is true or not. Just multiply 8 4 the 32 by 3, and this multiply, then 4 root 3 by 3, it is 4 by root 3. That is the correct option, is the C answer. So this is the external region. Now continue 19. Also very G and simple sum. Find the area bounded by two curves and y-axis. This is also IMP MCQ. The area bounded by the y-axis, comma, y is equal to cos x and y is equal to sin x, when 0 to pi by 2. Very easy. First, students, I will take both between bounded region. So y is equal to cos x and y is equal to sin x. Just you simplify on it. So students, cos x is equal to sin x, tan x is equal to 1. They are 45 degree, and if you x 45 putting, surely y become 1 by root 2, because here put it sin 45 1 by root 2, either cos 45. So your drawing is ready. 0, 45, 90, and upper sides you taking the values for 0 and 1, and then way to define your answer. So now students, you putting the sign limits. Sin 0 0, sin 90 1, here 1 approximately. This graph is moving away this side, so y is equal to sin x. And if you cos putting, then cos 0 1, cos 90 0, this side moving, your cos graph. And between is 0 to 90, it means your boundary is this, but I want to only related y-axis. Read the questions properly. This curve and y-axis, only that. So this is your limits for pi by 4, but y is 1 by root 2. Very easy. Fx minus gx, this is y is equal to cos x graph. So required area of region 0 to pi by 4, fx minus gx. Now fx and gx putting any one. So 0 to pi by 4, it is your sine minus cos, either cos minus sine. Anyone you put it down, students, it is absolutely true. Now integration sin x, here plus cos x, and boundary 0 to pi by 4. Now sin 90, 45, 1 by root 2, cos 45, 1 by root 2, minus, now lower limit put it, sin 0 0, cos 0 1. In short, your data is done 2 by root 2 minus 1, it is root 2 minus 1. It is option wise you tick mark. I think your option is B. In your questions textbook read, students, it is your option B. Yes, root 2 minus 1, and that is the correct. Now I am moving to two remaining examples, miscellaneous examples 14 and 13. 11, 12 and 13 already I explained you in the fourth video. So here I going to big two examples are remaining. Example number 14, which is very most IMP. Example 14. Prove that the curves y square is equal to 4x and x square is equal to 4y. Y square is equal to 4x and x square is equal to 4y. Divide the area of the square bounded by x is equal to 0, comma, x is equal to 4, comma, y is equal to 4 and y is equal to 0 into 3 equal parts. Yes, into divided 3 equal parts. Very interesting numericals. First of all, students, I just define both given parabolic parts a common intersection points. So y square is equal to 4x and x square is equal to 4y, and both common region decided. So here y become x square by 4, and this y you plot down the here value. So just y I known x square by 4 whole square is equal to 4x. So x raised to 4 by 16, 4x. And now students, you just simplify on it. Simple define x value. So x raised to 4, 16 4 the 64x minus 64x, common taking x will do x cube minus 64. And here students, two values are available. One kind of x is equal to 0, otherwise x raised to 3 minus 64 0. So students, x is equal to 0 sure, x cube is equal to 64, x is equal to 4 sure. And now define y. So what is your y? 0, and here also 4, putting either here, either here. So common point is reading 0 0 and 4 4. Now I actually calculate the integrations by the drawing properly. I want to proving area bounded by this two parabolic part in the 3 equal division of the square area. So I just plot square wise two parabolic shape, y, here x. Students, first of all plot the square. This is x axis, y is equal to 0, y axis, x is equal to 0. Here your line passing through 4 points, x is equal to 4. Same here, line passing through y is equal to 4, it is 0 comma 4. And this point is the common point 4 comma 4 already I calculate. So my first parabolic part is moving away to this sides. Properly draw. That is a very easy figure. Y square is equal to 4x. Secondly, this side moving. It is x square is equal to 4y. And between us 3 region are decided, A1, A2 and A3. I just make the different kind of shading. One of the A2 is this shade, bounded between both. Second is this, different shaping given, that's why you understood there are the different but area is same. And third is dot dot dot, this way. This 4 length, this 4 length, this 4 length and this 4 length. First I calculate A1 bounded by this region, this the region, x square is equal to 4y. This moving, no? So for x square is equal to 4y, y become x square by 4, bounded between x is equal to 0 to x is equal to 4. And area A1 calculate, either you can naming here O, A, B, P, Q, R. Area of O, A, B, P, O, again O, A, B, P, O, this one only. And this area OA, BPO area is bounded between 0 to 4, y dx, and y become x square by 4. And simple calculation, x raised to 3 by 3, 4 3 is 12 and 0 to 4. So students, 1 by 12 same, here 4 cube minus 0 cube, and answer declare 4 raised to 3, 64 by 12, that is 16 by 3. 4 3s are and 16 4s are, yes, 16 by 3, 16 4s are and 3 4s are. This is your first area is declared. Now I moving to this middle area, both parabolic parts between bounded 0 to 4. So both subtractions. Very easy. So continue. I moving ahead. So parabolic part x square is equal to 4y. It means y is equal to x square by 4. I will take fx. And secondly is y square is equal to 4x. So we will do y is equal to 2 root x, which is gx. Area, both curve between, it is this A2 region. So A2 region bounded between 0 to 4 confirm. I will show here area of O, P, B, Q, O. Again ready? O, P, B, Q, O. And that is the final 0 to 4 fx minus gx. Students, as you wish, gx minus fx also true and fx minus gx also true. So A2 region 0 to 4. First fx you told x square by 4 and the 2 root x dx. So x cube by 3 minus 2 3 by 2. X cube by 3, not x cube by 3, 4 is 12. Yes, by mistake I written, and limit I have 0 to 4 as it is. So finally you calculate here 4 cube by 12 minus 2 by 3 and 4 is to 3 by 2, 64 by 12. And here to do the 4 by 3 but had known 2 square, 3 by 2, 2 to cancel, and final calculations. Your answer 64 by 12. Here 4 by 3, 2 raised to 3 is 8 and 8 4s are 32. So students, 64 by 12 minus 32 by 3, can I write down extra 4? So it will get 4 by 3, 8 4s are 32 by 3. And students, here calculations, extra I write down 4. So 64 minus 4 2 is 8, 4 3 is 12, 128. So minus 64 by 12. And area never be negative. So you will write down A2 is a 64 by 12, 16 by 3, 16 4s are 4 3s are. In short, your second area is also same coming to A1 and now A2 same. Now going to A3, bounded by y-axis by this curve. No, this curve bounded. See, y square is equal to 4x. Between y-axis for 0 to y taking, and I separate in the y forming. So my third area, A3 area, bounded by this curve. I mean y square is equal to 4x. So for y square is equal to 4x, you will separate x, y square by 4. Between y is equal to 0 to y is equal to 4. I again repeat, why I taking, it is the launching on the y-axis my A3 area. So area of O, Q, B, R, O. O, Q, B, R, O, Q, B, R, O. And that is the finish easily 0 to 4 x dy. Dy means launching on y-axis. And 0 to 4, what is the x? Y square by 4. And this calculation, sure answer is 16 by 3. Y cube by 3 means 12. Limit 0 to 4. So 64 by 12. 16 by 3. Statement 3. Now final write down one more, area of square. The square already naming OABR. OABR, which is side square, already known, 16. Statement 4. Now my target, divided into 3 equal parts. So that's now I proofing the final statement of this numerical. So A1 plus A2 plus A3 will do 16 by 3, 16 by 3, 16 by 3, 3 times of 16 by 3. Your answer is 16, and check, it is the area of square is equal to area of square. Therefore, we can say thus both parabolas x square is equal to 4y and y square is equal to 4x divide area of square in 3 equal parts, and that's the finish our happily these questions. Now students, last question our remaining in this chapter, question number 13. After now I am moving to 14th one. This is also IMP for exam. Question number 14 I will write down these sides. Last question. I hope you understood very well this chapter fully. Now question number 14, example. Find the area of the region x comma y such that 0 less than y less than x square plus 1, 0 less than y less than x square plus 1, comma 0 less than y less than x plus 1 and 0 less than x less than 2. Again one more time repeat, 0y x plus 1 and 0 x with 2. Students, here also these IMP questions, so tick mark in the most IMP list. Now first of all, given inequality I will translate into simplest our curve. So these are the represent 0 less than y less than x square plus 1, one kind of 0 and one kind of x square plus 1. Second same, 0 less than or equal to y x plus 1. So here also y is equal to 0 and y is equal to x plus 1. Third, 0 less than or equal to y x less than or equal to 2. It means x is equal to 0 and x is equal to 2. So does here you launch the simple table for regarding this one, x y become x plus 1. You just putting the value. Here also you launch the table for better plotting your graph, and both common region I will explain here, y is equal to x square plus 1 and x plus 1. This both common region I will decide it. Very quickly I will plot my drawing. X square minus x is equal to 0. These are the 2 points. One kind of x is equal to 0 and another is 1. But students, if you x0 put it, y is 1. But if you x1 put it, y is 2. It means in both figure x0 y1, x0 y1. Put it here x0 y1, here x0 y1. Next is 1 2. Here also 1 2. 2 point is simple. If you put it here x0, now y0, x is not defined. X square minus 1 not possible, so infinity it is. And here are 2 point. I will show my drawing, and finally I did my answer. So start our simple drawing. So does my drawing is some kind of this way. This is your x-axis, this is your y-axis. First I plot this line 0 1, next 1 2, here 1, approximately here 2, this is 1 2, and this moving your straight line passing through on it. And curve x0 y1 is means this one, 1 2 is this one, and infinity is not touching the x-axis. Your graph is moving these sides that way. Just you plot, that are the boundary. This bounded between first graph is ready. Between is, why this between is I taking? Because you given to less than or equal to. And secondly asking 0 to 2. It means here you launch one of the line 2 comma 0, and this point also if you put it 2, x is 2, y is 3, 2 plus 1, so this point is a 2 comma 3. This is your another shading, because I want to between these all regions to one kind of this A1 region bounded by parabola, and second A2 region bounded by the line. Line is a y is equal to x plus 1, and this parabola is equal to y is equal to x square plus 1. Now start simple solution. So for parabola y is equal to x square plus 1, I only explain this between x is equal to 0 and x is equal to 1. So what is the area of A1 bounded? 0 to 1 y dx, 0 to 1 x square plus 1 dx, and simple calculation. So students, my answer is x cube by 3 plus x, 0 to 1. So 1 by 3 plus 1, it should be 4 upon 3. First region, students, this region is done. Now 1 to 2, but line represent, not a parabola represent. Okay students, so my second region is easily and happily I declare here by these solutions. So for the line, my line is a y is equal to x plus 1 bounded between x is equal to 1 to x is equal to 2, 1 to 2, and area of A2. So does here I think just write down the area for naming O, A, B, P, Q. Area of O, A, B, P, Q is equal to A1, students. It is 4 by 3. And here I will take naming to this part. Also here write down R and S. So A2 is called area of what? B, A, R, S, B. Will do 1 to 2 y dx. 1 to 2 y dx means only line represents 1 to 2, but what is the y? X plus 1, which is x square by 2 x, and here 1 to 2. So students, 2 putting 4 by 2, 1 putting 1 by 2, so this cancel. 2 plus 2 will do 4, and here 3 by 2, so 8 minus 3 by 2, which is 5 by 2. Again 4 to the 8 minus 3 by 2. Now A1 and A2 both you added, so required area of region will do A1 plus A2. What is the A1? A1 is a 4 by 3, but A2 is a 5 by 2, and simplify on it. 3 to the 6 LCM, 4 to the 8, and 5 3 is a 15 plus 8, 23 by 6 square units. And students, this is your final answer. I just check my answers. According to your textbook, answer is 23 by 6 is correct, students. Yes students, here our this chapter is happily done. I hope you understood properly and enjoying this all 9 videos. Thank you students, and we meet again in the next chapter in the next video. Bye bye.